This is wrong. This is so wrong. When I was a little kid in the 1980s, electric clocks which ran on the full AC line voltage and had a continuously sweeping second hand were a common sight. In fact, many homes had a special recessed outlet mounted high up on the wall for powering one. But by the 1990s, more and more of them started being replaced by quartz clocks, which have a ticking second hand and consume so little power that they can run for years on a single 1.5 volt AA battery. So for most people, the inconvenience of needing to replace the battery every once in a while is more than outweighed by the benefits of not having to plug it into an outlet and not having to reset the time every time the power goes out. So as a result, AC powered clocks have pretty much disappeared from the consumer market. You do still see AC powered clocks in commercial and institutional settings like schools, hospitals, and train stations, but for everyday household use they've pretty much disappeared, and it's almost impossible to find a new one today, except for this one. It's made by a company called Chicago Lighthouse. It costs about $33, and it says on the box it's an electric wall clock. It's the model 678-01103, 14.5-inch electric wall clock. And if I open up the box, here it is. It says the Chicago Lighthouse Electric Quartz assembled in USA. And it's so big I can't even fit the whole thing on camera. But the unusual thing is, it runs on AC power. It has an ordinary 120 volt AC power cord on it. It's definitely a new product. This one was made in May 2023. But it doesn't use an old-fashioned AC motor to run the clock. It uses the same kind of quartz clock mechanism as battery-powered clocks. It even has the space for where a AA battery would go, but instead it says no battery required, and instead, right into that quartz clock mechanism, which normally runs on a 1.5 volt battery, it has the power cord feeding 120 volts AC. How does that work? Here's one of those standard quartz clock mechanisms which I took out of a broken clock. It says Youngtown Quartz, made in Taiwan, no joules, unadjusted, and it's model 12,888. You can still buy these today for around $5 for just the mechanism, or for around $10 for a complete kit, including the hands to make your own clock. And there's where the 1.5 volt AA battery goes. There it is with the cover removed, and all you really see is a bunch of plastic gears and a big coil of wire. But if I disassemble it further, which will probably result in all those gears spilling out, you can see the electronics. And there is the quartz crystal, which pulses 32,768 times a second. And if you divide that by 2, 15 times, you get a pulse every second. And that pulse powers this coil, which kicks the second hand by 1 second. And that's why these clocks tick instead of having a continuous movement of the second hand. In addition to that quartz crystal, there's also an integrated circuit under this blob. And really that's about it. You have the crystal, the integrated circuit, the coil of wire, and the whole thing runs directly on 1.5 volts DC from a single AA battery. Now the question is, how can you take one of these designs and run it on 120 volts AC? Here's the mechanism in the new Chicago Lighthouse clock, and it doesn't have any terminals for where the battery would go, but that's clearly where it was originally designed to hold a AA battery. But they put a sticker saying no battery required. It says Quartex, USA Engineering and Quality, made in China. And there's clearly not enough room in this little plastic box to fit a transformer. You can see how thin it is. Before I possibly destroy it in the process of trying to figure out how it works, I thought I should show it working. So here it is. I'm going to plug it into AC power. That's interesting. It stayed still for a couple seconds before it started moving. Almost like it's charging up a big capacitor or something. Otherwise, it makes the same standard ticking noise. There's no AC hum or anything. Now I'm going to unplug it and I'll see if it stops instantly or if it keeps running for a few seconds beyond when I unplug it. No, it stopped pretty quickly. I'll plug it back in. And this time there wasn't that long delay before it started moving. Just one thing I noticed is that unlike most old-fashioned AC motor wall clocks, which have an externally adjustable time adjustment knob, usually on the bottom, this one does not. So you'll have to take it off the wall to adjust the time. And they give you this very tiny little thumb wheel which takes a lot of rotations to move the time. So if the time indicated on the clock is far away from the actual time, you're going to spend quite a bit of effort trying to adjust it. Now I'm going to try to pry it open without destroying it. Wish me luck. Okay, well, it mostly looks the same. We have the same bunch of plastic gears and coil of wire, but instead of the AA battery, we have the 120 volts AC coming in right here. Then there's 4 diodes, which form a bridge rectifier and a smoothing capacitor. One thing I do know is that because this runs on rectified DC instead of directly on the AC, that means the frequency of the AC doesn't matter. It does not use that as a timing reference, unlike the old-fashioned electric clocks, which used an AC motor to run the mechanism. So you can run this on either 50 or 60 hertz AC power, and it'll keep accurate time either way. And I was also able to look up the battery-powered version of this mechanism, and everything inside this clear plastic box is identical. It's only the circuit board it's mounted onto that's different. So I'm going to need to disassemble this further to try to see the bottom of this to figure out what's going on. But before I go that far, I left it running overnight, and it is keeping accurate time. And I noticed it's just barely getting warm to the touch around here, so there's definitely something in this mechanism which is dropping down the voltage and producing a little bit of heat in the process. Thankfully, I was able to disassemble it non-destructively, but there's just so many things wrong with this. First of all, there's no strain relief on the power cord. You can see where it's kind of been crimped by the plastic casing, and that's it. The 2 wires are just split apart and the case goes on top of it, and that's it. Now if we take a closer look here, one side of the AC line goes directly into a surface mount resistor. I've never seen that before. I mean, are these little tiny resistors even rated for 120 volts? Because normally they only run at 5 volts or less. It's so small you probably can't read it, but it says 203 on it, which means it's a 20K resistor. And I noticed on the case here, it says 120 volts AC, 60 hertz, 0.4 watt. So if they're drawing almost half a watt through this little resistor, it's no wonder it's getting warm. And you'd think that dropping resistor would be connected to the hot side of the AC line, but if I connect one of my multimeter probes to the hot terminal on the plug, which is the smaller blade, but if I touch it with the other probe, we get nothing. The hot side of the AC line is actually coming in here, which seems like it should be the ground plane because it has all this connected to it. And if we follow the path of continuity from coming in there we go all the way over here, and look how close that is to the screw holding together the clock mechanism. Right here is connected directly to the hot side of the AC line, and that's the screw holding the thing together. There's like, what, 2 millimeters of clearance there? And if we follow the path around here, that's hot. Go down here, that's hot, right next to this integrated circuit. And then we go down here, which would have been the battery terminals if this was the battery version. That's connected to the AC line. So it's a good thing they didn't put any battery terminals in it, otherwise you could reach in and touch the AC line directly. And if I connect my multimeter probe to the neutral side of the AC line, which is the wider blade on the plug, that is connected right here, which goes to that dropping resistor. And that's where the continuity ends because it's going through that resistor. So you'd think this would be the hot side and this would be the neutral side, but they reversed it. These are all the diodes forming the bridge rectifier, and here's the smoothing capacitor. So if we follow the output of that, it goes around here directly into that integrated circuit. So I'm going to try to carefully measure what is the voltage coming out of that smoothing capacitor into the integrated circuit. Because you can see it's designed to run on batteries with these terminals, so you think this would be 1.5 volts DC coming in on this side approximately. So they're going to be dropping a lot of voltage to go down from 120 volts AC to 1.5 volts DC. Okay, right now it is plugged in and connected to AC power, so I'm going to be very careful. And if you're going to do this, you should be too. The multimeter is set to measure AC voltage, so I'm going to probe across the AC line right here. Yep, 120 volts approximately coming in. Now, let me see what's coming out of that dropping resistor. What? 2.3 volts AC? It really is dropping all the way from 120 to 2.3 volts? That's a lot of drop to put on that little surface mount resistor. Now the multimeter switched to measure DC voltage, and I wasn't even sure where would be a safe place to measure it, but then I realized, what about these battery terminals? So if I go across that, about 1.8 volts. So if this actually was connected to a battery, it would charge the battery. So yes, they're definitely running that chip on about 1.8 volts, which seems okay. That's probably within the tolerance of what it was designed for. But the vast majority of that dropping down from 120 volts to approximately 2 volts is through that tiny surface mount resistor. That's amazing. So, what a weird design. To be fair, it's completely encased in plastic when it's installed, so there's no shock hazard to the user. But still, you're putting a lot of faith in that little surface mount resistor. Well, it's all back together except for the plastic cover. I want to make sure I got all the clock hands properly aligned before I put this back on. And thankfully it's still working. And I don't mean to imply that this is in any way a dangerous product, because like I said earlier, I left it plugged in overnight and it only got mildly warm to the touch near where that dropping resistor is. But it's definitely a very weird and unconventional design, which seems to break a lot of rules about electronics and the way it works. So if you want a new AC powered wall clock, this is pretty much your only choice from Chicago Lighthouse, and it is assembled in the USA, and in this case it was reassembled in the USA as well.